In an effort to expand the often limited breadth of student design projects, this year the teaching staff of Stanford's CS247 Interaction Design Studio partnered with the Reuters Digital Vision Fellows to provide mentorship for student groups. This video will outline the structure and philosophy of the class and then show a selection of student work for the final project. The class was taught by Bill Verplank, interaction designer, human factors engineer, and visiting scholar, and Scott Klemmer, assistant professor and co-director of the HCI program at Stanford University. They were assisted by Bjorn Hartman, a PhD student in the computer science program. The class was organized as a 10-week studio course with 48 students participating, as well as a few frequent visitors. The central organizing principle of the class came from Bill Verplank's framework for teaching interaction design.
This is a drawing from Bill, which talks about the different phases of design. And you can start a project by thinking about an error that you have.
The first stage of this project was learning to sketch.
I would try in the paper log, put everything you can think of. Carry it with you as much as you can. So this is my definition of interaction design. As you design things, think about the person who's going to actually interact with this thing that you're designing.
Students learn to use idea logs to keep track of their ideation throughout the quarter.
A free-flowing kind of stream of thought, whatever comes to your mind. You're sitting down at the cafeteria for lunch, pull out your idea log, throw in a couple of quick sketches, externalize your ideas so that we can follow what your ideas were.
These idea logs were created using digital pen technology, which allowed students to quickly transfer their notes from pen to computer, and then share and annotate these notes with other students in the class. The task now was to go out into common spaces and find examples of designs that lead to errors. Don Norman's design of everyday things proved an invaluable source of inspiration for the types of errors identified. Students produced posters of their findings, along with proposed solutions. For the second project, the students took a trip to San Francisco to observe the weekly farmers market near the Ferry Building. Students took their idea logs to the farmers market and used them to record everything from sketches to statistics to interviews with the farmers themselves. After gathering data and identifying the needs of the booth owners, students storyboarded their proposed ubiquitous computing interventions. Next, they built rapid prototypes and presented skits to aid in conveying their ideas and to body storm the pros and cons of their proposals.
Photo of our beautiful herd of cows. We try to keep them healthy and happy.
What are you making? I'm making this French dish, some kind of casserole with potatoes and apples.
I'm all done with my coffee. Do you want to try that tree thing you started with?
Let's check out this tree.
Hey.
What's up with this?
It's really beautiful.
Now that the students had experience with the observation and ideation phases of Verplank's framework, it was time to move into design analysis. In order to give students a focus to draw upon for the third and fourth projects, the instructors partnered with the Reuters Digital Vision Fellows program. This program provides backing for several fellows to conduct research and implement solutions worldwide. Some of the mentorship projects presented included the introduction of computing into underserved communities in Brazil, rapid disaster preparation, time scheduling for youth, and creating a connection between garment makers in India and consumers in the United States. Though each mentor had a different focus, the coherent whole presented by the group provided a consistent theme for the class, regardless of which mentor each group paired up with. Since the mentors were not clients, but instead sources of guidance, the relationship was different and more of a partnership than in the client and student designer relationship present in other classes. After partnering with the mentors, students built a screen-based prototype that would address the need of their mentor's target group. This served as a launching point for the final project, where students were asked to move beyond the desktop and into the realm of physical prototypes. Projects created for the final presentation tackled real-world problems in tangible ways. Students overcame the fear of physical device building common to many computer science students and delivered several innovative solutions, with projects ranging from smart hangers to a remote stethoscope. The user tests performed by all groups allow them to iterate on their physical prototypes, learning valuable design and need-finding lessons along the way. Two of the projects mentored by Saori Fortenos, a Brazilian fellow, were invited to take part in the Maker Fair, a 2-day exposition in San Mateo that featured innovative physical creations. The first of these, Nossa Música, was a collaborative music-making toy for children in Brazil, meant to enable multiple children interacting with one computer, a need highlighted by conversations with the project mentor. While building this prototype, students had to seek proxy users in underserved communities in the Bay Area, which provided an approximation for the target users. The second project featured at the Maker Fair was Palette, a tangible color mixing device that uses physical paint buckets to allow up to 4 children to mix color together. This product was also intended for use in Brazilian schools. Using the D-Tools Rapid Physical Prototyping Kit, the Palette Group built a tilt sensor-based physical device and tested it with children in the Bay Area. Both projects were successful attractions at the Maker Faire, with thousands of curious visitors. The introduction of mentors as partners proved to be highly successful. Students were able to step outside their usual environments and build projects with empathy and understanding for their intended users.